welcome you on behalf of the Victoria Naturally Alliance to Saving Victoria's Nature in a Changing Climate. So we're on the traditional land of the Kulin people, and we show our respect to the elders past and present. So thank you all for joining us today. I'd like to introduce myself. My name is Carrie Deutsch, and I work with the Victoria Naturally Alliance. The Victoria Naturally Alliance of 9 environment groups is hosting this forum today about what we can all do to respond to the crisis facing biodiversity in Victoria. The Alliance is hosted by the Victorian National Parks Association and includes the Wilderness Society, the Australian Conservation Foundation, Environment Victoria, Greening Australia Victoria, Trust for Nature, Bush Heritage Australia, Bird Observation and Conservation Australia, and the Invasive Species Council. And this event is possible due to the support of all the member groups. So on behalf of the Alliance, it's my pleasure to welcome our friends and colleagues here today and to give a warm welcome to our panel, Professor Will Steffen, Dr. Paul Sinclair and Karen Baker. We're having this forum at a time when the world is facing global crises, climate change, mass extinction, and here in Victoria, we're all aware of the very dire situation facing our biodiversity. Over half of the state's native vegetation has been cleared, and 30% of Victoria's animal species and close to half of our plants are already extinct or threatened with extinction. Clearly, much more needs to be done for the diversity of life in Victoria for our biodiversity. So we're already facing a crisis, but on top of this, climate change has major implications for our wildlife and our native habitats. So I'm sure Will be telling us much more about that. There are many conservation challenges facing us in Victoria. Today we'll hear about some of those challenges and also some of the inspiring solutions and what you can do to help. So today it's my great pleasure to introduce our first speaker, Professor Will Steffen. Will is the Executive Director of the Australian National University's Climate Change Institute. He was previously Director of the Fenner School of Environment and Society and Pro-Vice-Chancellor of Research at the Australian National University. He is a Science Advisor at the Department of Climate for the Australian Government. From 1998 to mid-2004, he was the Executive Director of the International Geosphere-Biosphere Program in Sweden, based in Sweden. He's the lead author of a book that was published at the end of last year, which I think we'll all want to read. It's published by CSIRO, and it's called Australia's Biodiversity and Climate Change, and it's the strategic assessment of the vulnerability of Australia's biodiversity to climate change. His research interests span a broad range within the field of Earth system science with this is a bit of a mouthful, Will, a special emphasis on terrestrial ecosystem interactions with global change. Emphasis on terrestrial ecosystem interactions with global change, the globe and carbon cycle, incorporation of human processes in Earth system modelling and analysis, and sustainability. So thank you, Will.
What I'd like to do is just have 3 different parts to this talk. Start with some basic climate science very quickly, Climate Science 101 and what is happening to the Earth's climate. But then I want to focus on Victoria's future climate. I put a question mark there because there's a lot of uncertainty about what's going to happen in most parts of the world when you get down to the scale of a state like Victoria. Nevertheless, I think there's some things we can say with confidence. And then the implications for biodiversity and what we can do about those implications. So let's start with basic climate science. That's a very long-scale graph. It goes back nearly 500,000 years, so it encompasses the entire time that humans have been on the planet. You see the carbon dioxide, and that's a graph of carbon dioxide in the atmosphere. It varies naturally from about 180 to 280 parts per million. But that red line at the end is the extra carbon dioxide that's gone into the atmosphere due to human activities since the Industrial Revolution. So we've had a massive effect on carbon dioxide in the atmosphere compared to natural variability. We know the properties of carbon dioxide. I could take you into a chemistry lab and show you how it absorbs heat or infrared radiation. So it's a no-brainer that this is going to affect the Earth's climate, and indeed we see that. The top graph is since about 1850, atmospheric temperature, global atmospheric temperature, and you see there's a lot of variability within years and even within decades. But the overall trend is that the Earth is warming, and that's absolutely of no surprise at all to climate scientists. On the lower panel, that's a very recent temperature graph, including the year 2009. And when you see that, you see that the temperature trend is continuously upwards with a lot of variability, and there has been no diminishing of the warming trend over the last decade, despite what you might see in the popular media. When we put the temperature increase on a longer-term perspective, we can see how different this is from natural variability. You may have heard a lot of people say, well, it's all just natural variability. Well, it certainly isn't from all the evidence that we have. This is a northern hemisphere air temperature record, and I use that because we don't have an equivalent record for the southern hemisphere yet. We haven't got the data down here as they do in the north. This goes back to nearly AD 0, it goes back to AD 200, the waning years of the Roman Empire. And you can see in the middle of this, the medieval warm period where it goes up a bit, and the Little Ice Age where it goes down a bit. But the red line at the end is the contemporary temperature change. That's post-industrial revolution, and you can see that that's quite different from any natural variability you've seen in the past. And I've put on there the so-called committed temperature increase due to the inertia in the climate system. So we're going to go right up off the chart, even if we cut emissions to 0 tomorrow. We see other evidence of change in the climate system. This is Arctic sea ice. That's the ice that's floating on the Arctic Ocean. You see the satellite images below. You see the data above. And that blue shaded area is what the climate models say the system ought to be doing. The red line is what the system is actually doing. So it's losing ice faster than any models project. It's one piece of evidence to support that we say the climate system is moving faster than we thought. Sea level is also rising. Here's the global data. From 1800s through the Arctic 1800 up to 2000. Sea level has risen about 20 centimeters since the Industrial Revolution. That rate is increasing. You see the Australian data in green, a little bit higher, but generally consistent with the global average. And this is data, I'm proud to say, comes from Australian researchers, and it's the gold standard globally of how we measure sea level rise. Okay, to sort of summarize Climate Change 101, this comes from the IPCC Fourth Assessment Report. Again, despite what you see in the media, there is no problem with this science. It's absolutely solid within the scientific community, despite the hoo-ha you see in the media. Three things to note. Warming of the climate system is unequivocal. That means we're 100% sure as scientists that the Earth is warming. There's some of the bits of evidence we see. But there are other changes in climate that have been observed at the scale of continents or ocean basins: wind, precipitation, salinity, ice sheets, extreme weather. All of these are important for the natural world and important for biodiversity, and I'll focus as much on these other changes as I will on temperature. The last one's very important. It is very likely, and that means we're over 90% sure that the main cause of this increase in temperature and these other changes is human-driven emissions of greenhouse gases in the atmosphere. That's all secure. There's no debate in the credible scientific community about those points. Well, what about Victoria's future climate? It gets trickier when you come down to a smaller region, because when you do that, a lot of the global trends tend to be masked by interannual variability or decadal variability. Nevertheless, I think there are three things I can say with a high degree of confidence, with a high degree of confidence about Victoria's future climate. The first one, it's going to be hotter. I think there's absolutely no doubt about that. For those of you, most of you probably live in Melbourne. I don't have to tell you about that. The heat wave of about a year ago, over 200 premature deaths. There were more deaths from the heat wave than there were from the bushfires in Victoria. Economic losses of close to $1 billion, 800 million plus, probably more than that. Now, the interesting thing is the frequency of these extreme heat events is expected to double by 2030 and to triple by 2070. So these will become much more common in the future. And that means we're going to have to do something to be able to adapt to it. A likely drying climate. And when you look at regional drying trends, I did a synthesis of this mid-last year for the Australian government, looking at all the data that we had to hand. And these are not model projections. This is my assessment of what we've already observed and what we understand and know about the behavior of the climate system. And I've broken up the drying trend. You see the drying trend in the background. That's a map of Australia with the wetting and drying from Bureau of Meteorology data from 1970 to the present.